Hello again, I'm Spiros, I'm from CERN. I work at the CERN Cloud team, and I'm going to talk to you about running a container service with OpenStack Magnum. I'm also the project team lead of OpenStack Magnum, so I will be a bit biased that it's a great service or something. Okay, so what is Magnum for you that don't know? It's an OpenStack API service. So this means that it runs an API server and authenticates with Keystone, and it has, as most OpenStack services, a conductor or engine. In our case, is a conductor. Magnum offers 4 types of clusters that I will explain later, and you can authenticate with your Keystone credentials. So what is important to understand how this service works is that Magnum has guarantees for multi-tenancy, and sometimes I try to explain it as multi-tenancy or single-tenant clusters. What this means is that each cluster is inside the tenant, and all the VMs or physical machines are in the same tenant. So all the containers that run in this cluster are isolated from one OpenStack user to another OpenStack user. So if you run a service on this cluster, this multi-tenancy goes away, and then it's up to the application to guarantee the multi-tenancy. So a cluster type is combined with a COE. COE stands for Container Orchestration Engine, and we support those 4, as you can see there: Kubernetes, Docker Swarm, Mesos, and DCOS. I will explain a bit the terminology of Magnum. So we have a Magnum cluster and a Magnum cluster template. The Magnum cluster has compute instances, neutral networks, security groups, volumes, load balancers, and all these are orchestrated are created with the orchestration service of OpenStack, which is OpenStack HIT. We have an abstraction of cluster drivers to support different backends other than HIT, but at the moment there is only HIT available. So the cluster is where the workload is running, and Magnum focuses on lifecycle operations of these clusters. So for now we support scale up and down, and for the next release hopefully we aim for rolling upgrades of the clusters and cluster healing and node replacement. So if a node is bad, you just replace it, you don't fix it. Also, the clusters come with self-contained monitoring. That means that for Kubernetes or for Swarm, we run a stack of Prometheus, node exporter, and CAdvisor to collect metrics from the node and the containers, and we project them in a Grafana dashboard, and this is like self-contained. In our case at CERN, we have also a central monitoring service, which is different, and users in our case that run clusters, they have their own monitoring for the cluster, and they can also push to the central monitoring service. A very strong point of Magnum that didn't start like this in the beginning is that now we support only the native COE clients to create containers and other objects in the COE terminology. And now we support only the native clients. That means that Magnum creates the cluster for you. It sets up a CA that is stored in Barbican or in the database or in the disk of where the Magnum controller runs. And then you can retrieve the credentials and communicate and create containers with the cluster using either Docker, kubectl, DCOS, or the HTTP endpoints like Marathon. This is the architecture of the service, and I will mostly focus on the right part to explain what exactly Magnum does. So you have the Magnum client or the OpenStack client on the right, and you talk to the to the Magnum API, which is like the normal OpenStack API, to create cluster certificates or cluster templates. And in the case that we are interested in is to create clusters, the API communicates with a conductor with RPC calls, and based on the cluster driver that you have selected, it creates a cluster with OpenStack HIT. And HIT creates compute resources, networking resources, block storage, and so on. Now I will talk briefly about some features that we had in Pike. What we were focusing in the previous 6 to 10 months is to be able to iterate very fast with COE versions. So Kubernetes and Docker have a very higher pace than OpenStack in releasing. They have every 3 months, and now Docker has every month. Okay, it's not a stable release, but they still release every month. And we were trying to be able to iterate on versions of Kubernetes and Docker without upgrading OpenStack. In many cases, okay, something is going in. This is better? Yes. So we're trying to iterate on the versions. No, still not. Okay, anyway, I will continue. We are trying to iterate in the versions of Kubernetes and Docker faster than the OpenStack releases. In many cases, operators have a single control plane. That means they deploy in the same nodes all the OpenStack services. For services like Keystone or Nova, you might not want to upgrade very fast, but for Magnum, for just upgrading the Kubernetes version, you might want to iterate faster. So we wanted to avoid that, and we started running Kubernetes in containers. And for the next release, we aim to also run the Docker daemon in a container to be able to iterate much faster and just set the version that we want to use. So for Pike, we also had some features related to Kubernetes only, support for core DNS and storing etc data, the etcd data in persistent volumes, and support for the Kubernetes dashboard, which is also an admin panel for Kubernetes. And we also added the swarm mode driver, because before Magnum was supporting only the legacy swarm that you run an agent in all nodes, like a container agent. For the Queens release, the main goals are the cluster upgrades, to be able to upgrade the clusters in a rolling fashion. Battery probably. And also try to implement cluster health monitoring and cluster healing. So if Magnum detects that a node is down, or the cluster was supposed to have 10 nodes, but 2 nodes are not responding or not behaving properly, just delete them and create new ones. Because in container clusters, this is how the workflow is supposed to work. You don't care about your compute resources. You must implement your application in a way that you are not bound to specific nodes. We will also try to add the different container runtimes. There is a hype in creating new runtimes like Clear containers, also Kata containers from the OpenStack Foundation, Docker containers or CRIO containers. And we will try to support also that. And I will share the slides, and at the bottom I have a link for the Queen blueprints that we are aiming to implement for this cycle. And the next slides are the most important that I wanted for this talk. So why would you like to use in the scientific space, why you want to use Magnum? So if you have an on-premise cloud or even a small one, and you have many users, you might want to run a managed self-service container service. This is very similar to the Google Container Engine and the new Amazon Kubernetes service, that you have, you describe what kind of cluster that you want, and with one API call or one click, you have your cluster running. So this worth to follow that path only if you have like more than 5 users and you have more than 10 clusters. If you have 5 or 10 clusters, you just manage them by yourself. And also, if you have an OpenStack cloud, you might want to use Magnum because accounting comes for free. Since all resources are OpenStack resources, and each cluster belongs to a single tenant, all the accounting comes like this. For example, at CERN we have quotas and projects. You can't exceed your quota in VMs. You can create as many clusters as you want, but if you have a limitation in the instance quotas or network quotas or block storage quotas, you can't go further. Also, what we noticed is that before Magnum, people were starting using containers all the time at CERN, but there was a steep learning curve from many of them in the beginning, and we had a lot more users using containers with Magnum because we had some public cluster templates that are ready for users to use them, and with one click they could get the cluster running and be able to use it. Also, I added the last bullet, I think last week, with Meltdown Spectre. Since the user doesn't manage the nodes, you control which operating system and which version you, the operator, which operating system are the operators are using. So in this way you can guarantee which kernel version they have. And this is the most important slide if you want to run Magnum. So before deploying it, you must design your network. This is the most tricky part. If you have a standard OpenStack deployment, like let's say deployed with OpenStack Ansible and you get all the standard features, it will work out of the box. But if you have a legacy data center and you start deploying OpenStack and you start doing witchcraft with your network, you must be sure that the heat will be able to create IPs and give floating IPs to all the nodes. Otherwise, you may need to have a standard private network that all your VRMs or physical machines are running there. Also, for multi-master, you must have deployed Octavia. Another very important key that we noticed from our experience is you must run your own container registry. Otherwise, you depend on Docker Hub that even if it has very good uptime, you also will suffer from latency. And it's better to rebuild or mirror all your containers in your organization. And the final point is that since you provide the self-service for container clusters, it's in a way you distribute software to your users. So you must have that in mind, that you must maybe upgrade Magnum regularly or maybe monitor which container images are you offering to the users and which glance images with the underlying operating system are you offering. So you must plan for that to be able to upgrade regularly and for new kernels, new Kubernetes versions, new Docker versions, or even new Prometheus versions. And now we'll go quickly to the CERN container service. These are the fancy numbers again. This I took it yesterday evening. What's important for me here is that for the Magnum clusters box, I used the same exact slide with different numbers in June, and we had only 60 clusters. Now we have 140, and since before that it was Christmas, I don't have, for example, me personally or my team, any clusters. So these are all user clusters. It's not us cheating. And yeah, the rest of the numbers, I think you can see, you have seen them many times. What we use our container service for, the most important part is for batch processing, and it's the same almost use case for SKA. So you have scientific workloads and you want to process them in batch with opportunistic maybe compute resources or not, and you just need raw compute power. So this scales very well with a container service that runs on Kubernetes or Docker Swarm. Other use cases are for infrastructure, web servers, etc. Continuous integration for us, run some OpenStack services. For example, Horizon runs on Magnum, and in a cluster that was created by Horizon before running it on Magnum. That was very fun. And we also have new use cases with TensorFlow and machine learning. And this is a timeline of what we did. But what I wanted to say about the scientific community is that we did a lot of work to integrate the identity part of CERN to our container service, storage access because we have dedicated specific file systems, and what it's very important and you might want to have a look at if you run scientific workloads is the CVMFS Docker storage driver that we wrote. CVMFS is a file system to distribute software, and we managed to do file-grained software container image delivery using the CVMFS infrastructure. So I will put a link under when I share my slides so you can have a look at that. And for the workflow, I don't think I have more time, but very quickly is that we have some public cluster templates, and like this, a user with one click can create a cluster, wait a few minutes to get 100 nodes. This is actually a true number. and then with one command does cluster config, gets the TLS credentials, and then from now on he stops talking to OpenStack and he talks directly to his cluster and creates the resources that he wants. This is the end of my slide. This is for questions and discussion if you want to have with Magnum. So just ping me in OpenStack containers. You can follow our meeting, and you can send an email to using the Magnum tag in the OpenStack operators or OpenStack dev mailing list. Thank you.